Have you ever stared up at the night sky, full of distant stars, and wondered about the vastness of time? Perhaps you've imagined skipping forward to see the incredible inventions of the future, or maybe you've dreamed of journeying back, to walk with dinosaurs or witness history unfold with your own eyes. This incredible idea, the ability to travel through time, has captivated humans for generations. It's a staple of our greatest stories, our wildest dreams. But is it just a dream? Or could the physics of our universe actually allow for such an extraordinary feat? Let's embark on an adventure to explore these mind-bending possibilities together. The thought of controlling time itself is truly profound. Imagine holding a remote control, not for your television but for the flow of moments, days and years. You could fast forward through a boring Monday morning or rewind to relive a cherished memory. This isn't just idle fantasy. Some of the greatest minds in science have pondered this very question. They have peered deep into the equations that describe our cosmos, searching for clues. Could there be hidden pathways, secret rules that might allow us to become masters of our own temporal destiny? The universe, as we are constantly discovering, is far stranger and more wonderful than we can often imagine. Think about it. Every second that ticks by feels absolute, unchangeable. Yet, what if time isn't the rigid, unyielding ruler we perceive it to be? What if it's more like a flowing river, with currents, eddies, and perhaps even shortcuts? This is where the journey into theoretical physics begins. We start to question our everyday assumptions about reality. Science fiction often shows heroes zipping through centuries in fantastic machines. While we don't have those machines in our garages yet, the theories that might one day inspire them are being explored in laboratories and on blackboards around the world today. Our quest to understand time travel isn't just about building a fantastical device. It's about understanding the very fabric of reality, the fundamental laws that govern everything from the smallest particles to the largest galaxies. It's about pushing the boundaries of human knowledge and daring to ask what if. So buckle up your mental seatbelts. We are about to dive into a world where time bends, space warps, and the future might just be a destination we can reach. This exploration will stretch your imagination and perhaps change the way you think about time forever. Are you ready to see what science has to say? Our first guide on this incredible journey is none other than Albert Einstein. What a mind! He completely revolutionized our understanding of space and time. Before Einstein, we thought of space as a fixed stage and time as a universal clock, ticking at the same rate for everyone, everywhere. But Einstein showed us something far more astonishing. He revealed that space and time are interwoven into a single, four-dimensional fabric called space-time. Think of it like a giant cosmic trampoline. This concept is absolutely central to any discussion of time travel, as it opens up possibilities we never dreamed of before. Now, here's where it gets really interesting for aspiring time travelers. Einstein's theories of relativity tell us that this space-time fabric isn't static. It can be warped and curved by gravity. Imagine placing a heavy bowling ball onto that cosmic trampoline. It creates a dip, a curve in the fabric, right? Massive objects like planets and stars do the same thing to space-time. And guess what? This warping of space-time doesn't just affect space, it also affects time. Gravity can actually make time run slower. This isn't science fiction, it's a proven fact. Clocks at sea level, closer to Earth's gravitational pull, tick ever so slightly slower than clocks on a high mountain. This leads us to a mind-bending concept called time dilation. Einstein's special theory of relativity also tells us that time is relative to how fast you are moving. The faster you travel through space, the slower you travel through time relative to a stationary observer. Imagine you have an identical twin. You hop on a super-fast spaceship, one that can travel at speeds approaching the speed of light, while your twin stays on Earth. When you return, even if only a few years have passed for you, decades might have passed for your twin on Earth. You would be younger. This is a form of forward time travel. Of course, reaching speeds close to the speed of light is an enormous technological hurdle. The energy required would be astronomical, far beyond anything we can currently achieve. However, the principle is sound. Time dilation is a real phenomenon, and it's even accounted for in everyday technology like GPS satellites. These satellites orbit the Earth at high speeds and experience weaker gravity, so their onboard clocks would run at a different rate than clocks on the ground if scientists didn't make precise adjustments. So, Einstein has already shown us that time is not absolute. It's flexible, stretchable, and a very personal experience depending on your speed and gravitational environment. So we've seen how moving incredibly fast can let you journey into the future. But what about traveling to the past, or taking a super-fast shortcut across the universe? This is where another fascinating, though highly speculative, concept from Einstein's theories comes into play: wormholes. Imagine taking that fabric of space-time we talked about and folding it over on itself. Then imagine punching a tunnel through the two layers. This tunnel would be a wormhole, a theoretical bridge connecting two distant points in space-time or perhaps even two different times. It's like finding a secret passage in the cosmic maze. The idea of a wormhole, sometimes called an Einstein-Rosen bridge, is incredibly tantalizing. Instead of spending millions of years traveling to a distant star, you could theoretically pop through a wormhole and arrive in an instant. And if one end of the wormhole could be manipulated, perhaps by moving it at relativistic speeds or placing it in a strong gravitational field, theorists suggest it might even connect different points in time. One mouth of the wormhole could be in the present, while the other could open up into the distant past or the far future. This is the stuff of science fiction dreams, isn't it? However, before you start packing your bags for ancient Rome, there are some rather large cosmic catches. Creating and stabilizing a wormhole would likely require something called exotic matter. This isn't the kind of matter that makes up you, me, or the stars. Exotic matter would need to have negative mass energy density, meaning it would essentially have anti-gravity properties pushing space-time apart instead of pulling it together. We've never observed such matter, and we don't know if it can even exist. So while wormholes are mathematically possible according to general relativity, their physical existence remains purely theoretical for now. Even if we could find or create exotic matter and build a stable wormhole, using it for time travel would open up a whole new can of cosmic worms paradoxes. These logical puzzles are what make thinking about time travel so mind-bending and fun. If you could travel to the past, what would happen if you changed something? Could you accidentally prevent your own birth? Or could you create a situation where an effect happens before its cause? These are not just philosophical musings, they are serious considerations for physicists exploring the limits of what's possible in our universe. The implications are truly staggering. Let's talk about the most famous time travel puzzle, the grandfather paradox. Imagine you build a time machine, go back in time, and accidentally or intentionally prevent your grandparents from ever meeting. If they never meet, one of your parents is never born. And if your parent is never born, then you are never born. But if you were never born, how could you have gone back in time to cause all this trouble in the first place? It's a perfect loop of contradiction, a real head-scratcher. This paradox highlights the potential dangers and logical inconsistencies of altering the past. Does the universe have rules to prevent such paradoxes? Another tricky one is the bootstrap paradox, or information paradox. Imagine a brilliant scientist writes a groundbreaking theory about time travel. You, a time traveler, read her work, travel back in time, and give her the complete theory before she has even thought of it. She then publishes it. So where did the information originally come from? It seems to have no origin. It's just stuck in a self-creating loop. Like a pair of boots pulling themselves up by their own bootstraps, the information exists without a clear starting point. This challenges our understanding of cause and effect, and the flow of knowledge through time. Some physicists propose solutions to these paradoxes. One idea is the self-consistency principle, championed by Igor Novikov. It suggests that any actions a time traveler takes in the past were always part of history. You can't change the past because your presence and actions were already factored into the events that led to your present. So, if you went back to stop your grandfather from meeting your grandmother, something would always intervene to ensure they still meet. Perhaps even because of your interference. The timeline is self-healing, preventing contradictions. It's a fascinating, if somewhat deterministic view. So, is time travel to the past truly impossible because of these paradoxes? Or are there ways around them, perhaps involving parallel universes or quantum mechanics? The truth is, we simply don't know yet. The quest to understand time, to perhaps one day navigate its currents, is one of the ultimate scientific adventures. While the challenges are immense, and the theories are still evolving, the human spirit of curiosity continues to drive us forward. The universe is full of mysteries, and the nature of time is perhaps the grandest of them all. Who knows what amazing discoveries the future or perhaps a visitor from it might bring? The journey of exploration continues.